Okay, it's fired up. And this has cruise control,
Okay,
so once I set the speed, I'm not fiddling, and we don't have guys under the garage.
you don't have any gerbils or anything
There's,
like that?
yeah, we don't have,
Okay.
there's just no funny business.
Okay,
Alright. It's hard to believe that there's no funny business, but there's no funny business. Like it's still hard for me to believe when I see this do what it does. It's
As
still,
an engineer,
well,
as a scientist.
no, I mean, to me, it's a miracle. It's a miracle of science. It's a miracle. And again, that bike motor, that wheel
Mm-hmm. Mm-hmm.
is not light.
Oh, no,
It takes a lot of energy to, this electric motorcycle
Mm-hmm.
is actually classified as an electric bicycle.
yeah.
It has pedals that go on here,
Yes.
just so you could say it's an electric assist bicycle,
Yes.
but you cannot pedal. You would, if we put the pedals on here, you would not be able to pedal it to the end of the driveway. It's just impossible. It's impossible to make it go, like the weight of it alone. Now, when you see these coils recharging the batteries and making it go faster, it's always a surprise to me. I often expect it to not work sometimes when I do a demo, because it's just,
Gotcha.
it's just what it is. because it's very hard on, the motor is like, try to
Understood.
overcome all that,
Yes.
yeah. So,
Yeah. Thank you very much for that
Wow,
so,
demonstration.
that's it, that's the,
thank you for going
Always,
online.
always a pleasure, thank you, thank you.
so, again, that's it. No, just leave it for a second, I'll wrap up. So, what the conventional scientific community doesn't know, or maybe they know, according to your rant, don't say anything, it's on camera. So, what they don't know, or they can't allow them,
Accept it,
well,
I guess.
if you start from the premise
Yeah.
that energy can't be created,
Mhm,
and that's what you believe,
mhm.
and that's all you believe, then you can't accept
This,
that generator armature reaction is negative work that's being performed by energy that's created at the subatomic level.
Gotcha.
You have to say that negative work is not being performed, even though it is. Because here we reduce the kinetic energy of the system. We performed negative work, but we also performed positive work. Like, that's clear. So, is the energy that's performing the negative work, is that disposable from the model, the evaluation model that says what's going on in the generator? Well, according to the existing model, it is.
Yes.
They don't use that, because if they did, they'd have to say, well, the law of conservation of energy doesn't apply, it applies in a pump.
Yes.
It doesn't apply in electromechanics, and it never has. And until somebody is willing to say that that's true, they won't be able to accept what's going on here,
Mhm.
because we are demonstrating beyond a shadow of a doubt that positive work is being performed by electromagnetic field
Yeah.
energy that's created at the subatomic electron level, and even that's easy to understand.
Yes.
Mhm.
Now the question is, and this is the opportunity for scientists, engineers. This is the opportunity. This is where somebody wins a Nobel Prize.
Mhm.
Okay? When an electron spins or rotates around the nucleus of an atom,
Mhm.
is it, and it's producing, and there's an electromagnetic field created around that
Yeah.
electron. Is that energy being created, or is it being created now, at this instant? In order to, my assumption is it doesn't, the question is, my assumption is that magnetic field that's created around the electron is necessary to keep it in that little mini orbit.
Mhm.
Okay, that's my, it's electromagnetism. Now, the question is, and if you can find an engineer or a scientist, the question they need to answer is the electromagnetic, that's why it's on tape, is the electromagnetic field energy being created? Like, if you could take that electron and stop it from spinning and rotating,
Mhm.
there's no more electromagnetic field. So, was it created during the Big Bang? If it was, you could almost get away with saying energy can't be created because it's always there. But if it's being created instantaneously as it spins and rotates, then energy is being created. Now, what I'm saying, what I'm showing, is that it doesn't really matter if it was created at the Big Bang or it's being created instantaneously. when that electromagnetic field, electron energy,
Yes.
is externalized around the wire, okay, this is the bottom line. It currently performs negative work in all EVs, in all generators. Hydroelectric is battling that energy constantly, and that's the bottom line for the world right now. That's why we have CO2 and air pollution, and that's why we have all the problems that we do. You delay that in the time domain, which is what we're doing here, and now that energy that performed negative work can now be used to perform positive work, and that's for the rest of eternity. That's that's humanity's new normal. That's our new energy foundation. So when you guys come here, I'm not interested in electric vehicles anymore. The technology is the beneficiary
Yes.
of the discovery. And if the discovery was, in 2007, electromagnetic field energy can be used to perform positive work. And then from there, we developed the IP around it to make that discovery useful.
Yes.
So my big thing is change the physics first. Change the physics first, and while you're doing that, put the technology in an EV. Because the guy, and that's why it's a shame that your guys aren't here, none of them are here. The guy that puts his PhD behind this and says this shit is real, and here's why, that guy is going to have a lot of work. That's going to be his life. And, so,
Gotcha.
and it's a simple matter of coming in here and validating what I'm showing. Like, I don't know how I would trick you guys, even if I wanted to, 1, 2, 3 different prototypes. This is a DC motor, those are induction motors. And again,
What did the professors at MIT say?
well, we took the original prototype that I built. That's the coils out of the original prototype.
Okay.
And when we put the generator on load and accelerated it, we went to MIT to say, what the hell's going on with our generator? And they said, we have no idea. And I said, there must be something in the textbooks, in the literature, in something where somebody else has discovered this. And they couldn't answer. It didn't exist. So then we went into RWU for the next 2 years to develop the backing theory and to build coils. I have a room full of coils, hundreds and thousands of coils, to figure out what makes it work, what makes it not work, what's the parameter that you really need, critical minimum frequency.
Yes.
Below that, it's nothing.
Gotcha.
And above that, it's everything. And then how do you maximize the performance? And then with regards to the technology, how do you build the intellectual property, and how do you create technology that's viable? Okay, that prototype there is not viable to take that and put it in an electric vehicle. And nor is it viable from a commercial standpoint. You wouldn't go to market with that because that's 2008.
Yep.
Okay, you go to market, this, answering the question that one of your guys said about the IP.
Yes.
You don't go to market with that because the IP is not mature. If it's not mature and you go to market too soon, somebody's gonna develop this
Yes.
and you're out of business. So, the innovation, the IP has gone through half a dozen IP iterations, meaning half a dozen changes, okay? So this is a commercially manufactured Regenx coil that can handle 100 amps. So, almost 2 kilowatts, okay? The core is too small to do that, but the coil is, the windings, the gauge of the wire will allow that. Now, there's another, we have other coils. These coils that are here and here, oh yeah, there's another, this coil here. This coil is commercially manufactured coil that'll handle 66 amps. These coils will handle 10 to 20 amps. So in developing the intellectual property, number one, what's the critical minimum frequency and why is that important? Number two, because when I put this together, if this ran at 1500 RPM instead of 3000, it wouldn't work. So it needs a certain speed.
Right.
That's number one. Number two, if you were getting, 1.5 to 5 amps out of one of these coils, up to 10 amps, what happens when you go to 60 amps? Do you lose the effect? No. Okay. Do you lose the effect when you go to 100 amps? No. So that's 3 points on a graph.
Yes.
It's relatively linear. That's enough to suggest that if you went to 1,000 amps or 1,000,000 amps, the effect should stay the same. If you operate with, with the existing parameters that are in
Yes,
place.
the premises, yeah.
So, there's no suggestion at this point in time that, and 100 amps is plenty for any EV per coil. You put 100 of those things in your EV and you're good to go. So, with regards to, when you're developing intellectual property, you want to make sure your IP is secure,
Yes,
and you want to make sure your technology is mature before you go to market.
absolutely.
And the technology will tell you when it's ready.
Yes.
Okay, and you're here because it's ready. You're not here like, we went to MIT, it wasn't ready.
Yeah.
We went so many places. We went to Magna International, Siemens was here a couple of years ago. So,
Did you talk to Stronach?
sorry?
Did you talk to Stronach at Magna?
Well, we talked to the EV department. We talked to, there's many, if you go on the document, the international OEM document that I sent you,
Yeah.
there's a page there that shows all the places that we went. And all the places that we did demos to. Like, it's crazy how many demos we did. But the bottom line was, the intellectual property wasn't mature. And if it's not mature, then you don't commercialize.
Yes.
And now it's ready to commercialize.
Okay.
Because we know, at least we know, if we put this coil in an EV,
Yes.
we're getting 100 amps out of our coil, per coil, and we're getting acceleration. And
Yeah.
this operates beautifully as a motor coil too.
Yeah.
So,
And then you look at the cost, you look at the whole components of the breakdown of.
well, it's, again, a motor made with this versus this motor, this motor, this motor,
Yeah,
the price is exactly the same.
okay,
It's not, it's not exotic material,
No.
this is regular copper. And that's another aspect of developing a technology and IP. If industry requires too much alteration, that's a problem.
Yes.
Now this in here, all you have to do to make this motor coil, I'm talking as we go to commercialization,
Mhm.
you just plop, this is a jig that holds the coils, and that's
Yes.
you just put them in the jig.
yep,
You just slide them in, and if here's the coil, here's the rotor that's in a car alternator, which
Yes.
is similar to what's in here,
Yes.
okay?
Yeah.
If one of these windings burns out, becomes faulty, you throw the whole thing in the garbage.
Yes.
Because you don't even buy a new alternator, you don't even buy a new core, you just throw it out and buy a new alternator. If one of these coils develops a short circuit, burns out or
just
whatever,
maybe insert the new one.
you take the coil out.
Yeah.
That's all you have to do. If you want more power out of your motor, put bigger coils in. Everything else can stay the same. And so you can't do that with
No.
No.
you can't do that
With
with
a conventional.
any conventional design. If the windings in one of these motors burns out, the motor goes in the garbage.
Okay.
That's it.
Perfect.
Thank you so much.
So
Thank you,
Appreciate
Norman.
it.
Thank you.
there's a lot more to talk about.
We have a
But
lot
that's
more
a
to
good,
talk about, but this is good enough.
That's a good start.